Okay, in this video, we're going to talk about actually chapter 2, dealing with the limits. So this whole chapter will be just based on limits. So here in the preview paragraph, here all the calculus is going to be based on the idea of limits. Now, not only are limits important in their own right, but they underlie two fundamental operations of calculus: differentiation and integration. Okay, and when we deal with differentiation, we're going to be calculating derivatives, and with integration, we're going to be evaluating integrals. Derivatives enable us to talk about the instantaneous rate of change of a function, which in turn leads to concepts such as velocity and acceleration, population growth rates, marginal cost, and flow rates. Whereas integrals, it enables us to compute areas under the curve, surface areas, and volume. Because of the incredible reach of this single idea, it is essential to develop a solid understanding of limits. So here we're going to first present limits intuitively by showing how they arise in computing instantaneous velocities and finding slopes of tangent lines. And then as we move on, we'll build more rigor into the definition of the limit, and we examine different ways in which limits arise. This chapter here will concludes by introducing the important property of continuity and by giving the formal definition of a limit. All right, so in section 2.1, we're going to be dealing with the idea of limits. So basically, we'll talk about things like the average velocity. Also, we'll talk about instantaneous velocity, where we're going to come up with the definition of a limit by finding the limit. And also, we'll talk about the slope of a tangent line. Okay, so let's start with average velocity. All right, so here this opening section illustrates how limits arise in two seemingly unrelated problems: finding the instantaneous velocity of a moving object and finding the slope of a line tangent to a curve. All right, and these two problems provide important insights into limits on an intuitive level. In the remainder of the chapter, we develop limits carefully and fill in the mathematical details. So first we'll deal with average velocity. Okay, so let's say we want to calculate the average velocity as you travel along a straight highway. Let's say you pass milestone 100 at 12 noon and milepost 130 at 12:30 p.m. So that means you travel 30 miles in half an hour. So your average velocity over this time interval would be pretty much 30 miles divided by half an hour, or 60 miles per hour. And by contrast, even though your average velocity may be 60 miles per hour, it is almost certain that your instantaneous velocity, that would be the speed indicated by the speedometer, varies from one moment to the next. Okay, so now let's define the average velocity. Here we're going to let S of t be the position of an object moving along a line at t greater than or equal to 0. The average velocity between times t equaling to a and t equaling to b would be this: v sub av, or the average velocity, that would be equal to s of b minus s of a divided by b minus a. Okay. And of course, S of t, of course, is the position of an object moving along a line, and t is the time. So we're going to use that average velocity formula to simplify this example, or to work this example. Excuse me. And it says The function s of t represents the position of an object at time t moving along a line. Suppose s of 1 is equal to 63 and s of 4 is equal to 111. And here I want to find the average velocity of the object over the interval of time from 1 to 4. So that's the closed interval from 1 to 4. All right, so let's start by writing that formula for the average velocity. So here V sub AV, or the average velocity, is going to be what S of V is minus S of A divided by the difference of B and A. Now we're told what S of 1 is and S of 4 is. So that means we're going to do S sub 4 minus S sub 1. And that's divided by, and of course, 4. This means that A is equal to 1 and B is equal to 4. So the denominator will be 4 minus 1. Because if you recall, the interval there is just from A to B. So your 1 is going to be A and the 4 will be B. Now, S of 4 is given to you as 111. So it will be it'll be 111 minus S of 1, that's 63. And that's divided by 4 minus 1 will be 3. So if I subtract 63 from 111, that will be 48. And then 48 divided by 3 is 16. So here, they don't give us the units here, but for time and also for the distance. So here, the average velocity would be pretty much 16. Okay, that's your average velocity. Now let's say that it was, these units were in miles, and then your time was in hours. So that means the average velocity would be 16 miles per hour. Okay. All right, now let's look at example 2. In example 2, we're told this: the position of an object. The position of an object moving along a line is given by the function S of t is equal to negative 18t squared plus 162t. And here I want to find the average velocity of the object over the following intervals. Okay, so starting with part A. Here I want to find the average velocity over the interval 1, 10. So here 110 is going to be the average velocity, the interval, and we want its average velocity. Well, there are two things I need to find out. I need to find out what S of 1 is going to be and S of 10 using this formula. S of t is equal to negative 18t squared plus 162t. So I need to know what that is for S of 1 and S of 10. So let's start with S of 1. Okay, that means t is going to be equal to 1. So I simply substitute t into this S of t function. So it'd be negative 18 times t, which is 1, and that's squared, plus 162 times t, that's going to be 1. And in this case here, 1 squared would be 1. So it would be multiplied by negative 18. That's going to be negative 18 plus 162 times 1 will be 162. And then negative 18 plus 162 ends up being 144. So at 1, S of t will be 144. And now I need to find out what my distance is when t is equal to 10. So again, I'm going to use what S of t is, substitute each t with 10. So this will be negative 18 times t, which is 10, and that's squared, plus 162 times t again, that's going to be 10. And then we simplify. 10 squared is 100 times negative 18 will be negative 1800, plus 162 times 10 will be 1620. Now, negative 1800 plus 1620 would be negative 180. Excuse me. So S of t is going to be negative 180. Now I know what S of t is, and I know what S of 1 is, and I have A and B, and in this case, A is 1 and B is going to be 10. So now I'm going to use that. I can find the average velocity using this formula, V sub AB, or the average velocity. That would be S of 10 minus S of 1 divided by B, which is 10 minus 1. Now, when I simplify this, S of 10 was negative 180 minus S of 1, that's 144, divided by 10 minus 1, which is 9. And then if I subtract 144 from negative 180, that would be negative 324. And negative 324 divided by 9 ends up being negative 36. Okay, so the average velocity from A being 1 to B being 10, that will be negative 36. Okay, now part B, from 1 to 9, I want to find its average velocity. From 1 to 9, I want to find its average velocity. Well, I already know what S sub 1 is going to be. I've already know what S sub 1 is going to be from part A. That's 144. So S sub 1 would be 144. Now I need to find out what S sub 9 is going to be using that S of t function. So S of 9, we just substitute t in with 9 in this function. So it'll be negative 18 times t will be 9, and that's squared, plus 162 times t. That's also going to be 9. And then we simplify. We do negative 9 and square it based on order of operations. 9 squared, well, just 9 squared will be 81. 81 times a negative 18 would be negative 1458. Plus, and in this case here, 162 times 9, that would be positive 1458. Okay. I'm going to do this off camera so I can just see if this is right. Negative 1458, negative 18 times 9 squared is negative 1458, and then 162 times 9 is also 1458. So negative 1458 plus 1458 would be 0. So at 9, S of t will be 0. All right, so now we can find the average velocity from 1 to 9. So this time, this will be S of 9 minus S of 1 divided by 9 minus 1. So S of 9 was 0 minus S of 1, that's 144, divided by 9 minus 1, which will be 8. And 0 minus 144 will be negative 144. Divide that by 8, and you'll get negative 18. So the average velocity from 1 to 9 for that S of t function would be negative 18. All right, now part C, from 1 to 8. These are closed intervals, and that means your endpoints are included. Okay. And again, we know what S of 1 is from parts A and B. That's 144. So we don't have to use that formula again to substitute your t with 1. But we need to know what S of 8 is going to be equal to using that S of t formula. So that means we're going to have negative 18 times, this time t will be 8, and that's squared, plus 162 times t again would be 8. All right, so let's see, negative 18 times 8 squared would be negative 1152. Plus 162 times 8, that would be 1296. So if I take negative 1152 plus 1296, that would give me 144. So S of 8 would be 144. And now we can find the average velocity. So average velocity would be S of 8 minus S of 1. That's divided by B minus A. And then here A is 1 and B is 8. 8 minus 1. And S of 8 is 144 minus S of 1. That's also 144. Divide that by 8 minus 1, which is 7. 144 minus 144 is 0. 0 divided by 7 is 0. So for this, the average velocity from 1 to 8 would be 0. And finally, part D, from 1 to 1 plus h. And in this case, they tell us that h is going to be greater than 0 and is any real number. All right, from 1 to 1 plus h, well, S of 1 is 144 from parts A, B, and C. Now we need to find out what S of 1 plus h will be. Now we're not looking for a numerical value, we're just looking for an algebraic expression when S is equal to 1 plus h. So that means we take our S of t function, substitute t with the 1 plus h. So that means I'm going to have negative 18 times the quantity 1 plus h, and that's squared, plus 162 times t will be replaced with 1 plus h. Okay. Now let's simplify this. Now, I'm going to bring down negative 18. And it's going to be multiplied by what 1 plus h quantity squared will be, which is the same as saying 1 plus h times 1 plus h. Now, if you want to, you can write like this and then use the FOIL method, which is this: 1 times 1, which will be 1. The outer 1 times h will be h. The inner h times 1 will be plus h, plus the last h times h, which is h squared. So in this case here, this will be 1 plus. I got 2 h's here, so that would be just 2h plus h squared. So 1 plus h quantity squared would be 1 plus 2h plus h squared. Now for the 162 times the quantity 1 plus h, I just use a distributive property by doing 162 times 1. That'd be 162 plus 162 times h. That'd be 162h. And now I'm going to take that 1 plus 2h plus h squared, and it will be multiplied by negative 18 using the distributive property. Negative 18 times 1 will be negative 18. Negative 18 times a plus 2h will be a minus 36h. And then negative 18 times the plus h squared will be a minus 18h squared. And then bring down plus 162 plus 162h. Now let's see if we can combine some like terms here. I got negative 18 plus 162. That would be 144. Let's see, minus 36h and a plus 162h would be a plus 126h. And then I got 18h squared. There's nothing to combine with that. So it'd be minus 18h squared. Okay, so that's what s plus 1 plus h would be. 144 plus 126h minus 18h squared. Now let's find the average velocity for this. That's, of course, s of 1 plus h minus s of 1. All that's divided by 1 plus h minus 1. This is again a, and that's b. b minus a. 1 plus h minus 1. All right, so now let's simplify this a bit. S of 1 plus h is this right here. 144 plus 126h minus 18h squared minus s of 1 was 144. Now, 1 plus h minus 1, here the ones add to 0, so that's gone. I'll be left with the h in the denominator. But let's look at this numerator. We can do something with that. 144 minus 144, that's gone. I can get rid of that. I'll be left with 126h minus 18h squared divided by h. And also, notice I got 126h and a minus 18h squared. There's a common factor that I can take out, which is the h. Okay, so I can factor out an h. That would mean 126h divided by h will be just 126 minus 18h squared divided by h will be 18h. And that's going to be divided by h. And notice I can divide out those h's. So the final average velocity will be 126 minus 18h. And that would be that final answer. Okay. So this deals with just average velocity and calculating the average velocity on an interval that's given with a given s of t function, which is a position of an object moving along a line. All right, next we'll look at, on the next page, any such line joining 2 points on a curve is called a secant line. The slope of the secant line, which is denoted by M with SEC, M with the SEC, for the position function on the interval t sub 0 to t sub 1 would be this. M sub SEC equal to S of T1 minus S of T0 divided by T sub 1 minus T sub 0. And since the average velocity is the slope of the secant line, here that average velocity would be equivalent to the slope of the secant line. So here it is right here. The average velocity is the same as the slope of the secant line, and it will be this. S of T1 minus S of T sub 0 divided by T sub 1 minus T sub 0. Okay. All right, now in this case here, this is the illustration of pretty much that average velocity, okay? Here we have a curve that's given to us, which is, of course, S of T. And let's say we have this line right here. That red line that you see here, we call that the secant line. That is a secant line. And what that means is this is a line that crosses the curve at 2 points. Okay, that's the secant line. And of course here, from T sub 1 to T sub 0, that's a change in time. And then from S of T1 to S of T0, that is the change in the position. And it ends up being the slope. Probably heard that word slope in other math classes. So that's your slope of the secant line. All right, now let's talk about instantaneous velocity. Instantaneous velocity. All right, when we compute the average velocity, we use the position of the object at 2 distinct points in time. Now for the instantaneous velocity, that's going to be computed at a single point in time. The instantaneous velocity at point T equals T sub 0. That's going to be determined by computing average velocities over intervals T sub 0 to T sub 1 that decreases in length. So as T1 approaches T0, the average velocities approach a unique number, which is the instantaneous velocity. And this single number is what we call the limit. All right, so if I go back to this illustration right here, here's T1 and here's T sub 0. Now, T1 has to be approaching T sub 0 for this to happen. Okay, so here's T1. It's going to get closer and closer to T sub 0. Now, let's say I have a point right here to the left of T1. Okay, so that means that the point here would be the value of S of T sub, let's say T sub 2 on the curve. And if I go from that point to, let's say T sub 0, that would be another secant line. And I keep drawing secant lines until I get closer and closer to 0. I mean to T sub 0. So like, let's say another point here, that be T sub 3. The point on that curve for T sub 3 will land right here. And if I connect that point to t sub 0. Okay. As you can see there, it's getting smaller and smaller and smaller. It's getting closer and closer to this point right here, to t sub 0. And it will end up being the tangent line. And of course, the tangent line, by the way, is going to be the point where the graph of the line touches that curve, because tangent lines always touch. So here's that point right there. And this line that I'm going to draw in green, as you will see here, we call that the tangent line. And this pretty much would be just the illustration of what a limit is, because limits would be pretty much as t approaches some value. We're going to find out what value will it approach, will it get closer and closer to as we let t approach some number. Okay, now let's look at this illustration here, this example number 3. Let's say we got s of t is equal to negative 16t squared plus 108t. That's your position function. Let's say we want to compute the following table with appropriate average velocities. And then we're going to make a conjecture about the value of the instantaneous velocity at t is equal to 1. Okay, so this is just going to be an illustration of what limits are. Okay, because when we're dealing with limits, we're not going to find an exact answer. We're going to find a value that this function would get closer and closer to when t approaches some fixed given value. All right, so let me go ahead and write the function s of t equaling to negative 16t squared plus 108t. Okay. Come to think of it, this is almost the same function as example 2, but it's not. All right, so let's find out what this average velocity is for the interval 1, 2. Okay, so let's start with, and in this case here, your A is going to be 1 and B will be 2. All right, so let's start with S of 1. Find out what that's equal to by substituting t with the 1. So it'd be negative 16 times 1 squared plus 108 times t, which is 1. And now, if we square the 1, that's going to be 1 times negative 16. That would be negative 16 plus 108 times 1 would be 108. And then negative 16 plus 108 would be 92. So at S of 1, using that position function, S of 1 would be 92. And now let's find S of 2. Using the same position function, I'm going to substitute each t with 2. So I get negative 16 times 2 squared plus 108 times t, which is 2. So here, 2 squared will be 4. 4 times negative 16 is negative 64. Plus 108 times 2 would be 216. And then if I add negative 64 to 216, I'm going to get 152. So at 2, the value of that position function would be 152. Now let's find our average velocity. Okay, and I'll write this up here. The average velocity is, of course, S of B minus S of A divided by B minus A. So here my average velocity from 1 to 2 would be S of 2 minus S of 1 divided by 2 minus 1. Well, S of 2 is 152 minus S of 1 is 92 divided by 2 minus 1, which will be 1. Now, 152 minus 92 would be 60. Divide that by 1, you'll get 60. So from 1 to 2, the average velocity for that position function would be 60. Okay, so I'll put 60 up here in this table. Now for 1 to 1.5, 1 to 1.5. So again, A is going to be 1, but this time B will be 1.5. Well, I already know what S of 1 is. That's going to be, of course, 92. And if you look at that table, you'll see that the A, the first number in that interval, is 1. So I already know what S of 1 is. At 1, that'll be 92. Now, we just have to find the second interval, the second endpoint, S of 1.5. So for S of 1.5, that would mean I need to substitute each t with 1.5. So it would be negative 16 times 1.5, and that's squared, plus 108 times t, which is 1.5. Now with this, I'm going to use the calculator instead of trying to, do it manually. Now here, negative 16 times 1.5, and then we need to square it, plus 108 times 1.5. And then hit enter. We'll get 126. So S of 1.5 would be 126. And now we need to find the average velocity. So your average velocity in this case will be S of 1.5 minus S of 1 divided by 1.5 minus 1. Well, S of 1.5, we found that out to be 126 minus S of 1, that's 92, all divided by 1.5 minus 1 will be 0.5. And 126 minus 92 would be 34 divided by 0.5. And that will end up being 68. So the average velocity from 1 to 1.5 on that interval will be 68. Now let's try from 1 to 1.1. Well, S of 1 is 92. But for S of 1.1, we just substitute the t in that position function with 1.1. So this will be negative 16 times 1.1, and that's squared, plus 108 times 1.1. Okay, so I'm going to go ahead and use my calculator to do this. Let's see, negative 16 times 1.1, and that's squared, All right, and then plus 108 times 1.1. This will be 99.44. So I'm going to use that whole decimal, 99.44, for S of 1.1. And then find its average velocity between 1 and 1.1. So this will be S of 1.1 minus S of 1 divided by 1.1 minus 1. Well, S of 1.1, that's 99.44 minus S of 1, that's 92. Divided by 1 minus 1.1 would be 0.1. So 99.44 minus 92 is 7.44. Divide that by 0.1, and you'll get 74.4. Okay, so that's the average velocity for that position function between 1 and 1.1. Now, what about from 1 to 1.01? Okay. And by the way, let me go ahead and fill in these numbers here in that table. That's 68 from 1 to 1.1, that's 74.4. So as you can see, this is going to be approaching a number. We don't know what that number is yet. Okay, so now let's look at from 1 to 1.01. Well, S sub 1 is 92, by the way. So that's not changing. But for S of 1.01, we have to substitute our T with 1.01. So this will be negative 16 times 1.01, and that's squared, plus 108 times 1.01. Let's find out what that's equal to. All right, negative 16 times 1.01, and that's squared, plus 108 times 1.01. This will be 92.7584. Okay. So that's what S of 1.01 will be. So again, we find the average velocity. That will be S of 1.01 minus S of 1 divided by 1.01 minus 1. So this is 92.7584 minus 92 divided by 0.01. Well, 92 minus 0.7584, 92.7584 minus 92 will just be 0.7584. I put a 0 in front, divided by 0.01. This ends up to be 75.84. So from 1 to 1.01, that will be 75.84. And finally, from 1 to 1.001. All right, so here, S of 1 will still be 92. S of 1.001. We substitute the T with 1.001. So this will be negative 16 times 1.001. And that's squared, plus 108 times 1.001. I'll put the equal sign there. So in this case here, simplifying this will be negative 16 times 1.001 squared plus 108 times 1.001. This will be 92.075984. All right. And now for the average velocity, that's going to be S of 1.001. That's going to be that number 92.7.075984 minus S of 1, that's 92, divided by 1.001 minus 1. And if I subtract 92.075984 minus 92, that will be just a decimal point, 0.075984 divided by 0.001. 1 minus 1 from 1.001. Divide that, you'll get 75.984. All right, so by looking at this table right here, we can see that as we let this second number in this interval get smaller and smaller and smaller, and we let this stay fixed, that means that average velocity will be approaching some number, which is in this case, it's going to be approaching approximately to 76. So this is what the limit is. And this is how we write limit, L-I-M, for the limit, as t approaches 1. Because those second numbers in the interval will be getting closer and closer to 1. Of the function s of t, that's going to equal to 76. This is what we mean by the limit, and this is the notation. L-I-M for the limit, and then you got t approaching 1. The limit as t approaches 1 of the function s of t will equal 76, because as we let the second number get smaller and smaller and smaller, get closer and closer to 1, then s of t, this function, will be getting closer and closer to 75. Okay? So this is what we mean by finding the limit. Okay. Here's another example of this, example 4. For the position function s of t is equal to negative 16t squared plus 115t, here we're going to complete the table shown below with the average, appropriate average velocities, and then make a conjecture about the value of the instantaneous velocity at t is equal to 2. So we're going to do exactly what we did in that last example. So what that means is this. Let me copy that function down. S of t is equal to negative 16t squared plus 115t. And then I'm going to find out what S of 1 is, and then S of 2, and then find the average velocities. All right, now, notice in these intervals, your endpoint B is fixed at 2. So let's see, S of 1 would be this. We just substitute the t with 1. And I might as well put this interval down here as well, 1 to 2. So at 1, this will be 1 times negative 16 is negative 16, plus 1 times 115 is 115. Negative 16 plus 115 will end up being 99. So at 1, S of t that function, the value of that function when t is equal to 1 would be 99. Okay, now for s of 2. All right, we replace a t with 2. So this will be negative 16 times t, which is 2, plus 115 times 2. And I'm just going to go ahead and use the calculator. Negative 16 times 2 plus 115 times 2. And this calculator does do order of operations, by the way. Oh, that needs to be squared, I'm sorry. And this should be squared. 1 squared will be 1 times negative 16 is negative 16. But here, this is going to be negative 16 times 2 squared plus 115 times 2. That'd be 166. Okay. Problem was I left the square off in s of t when I evaluate when t is equal to 1. All right, so now let's find the average velocity. That's going to be s of 2 minus s of 1. And I'll go ahead and write that out. Divided by 2 minus 1. Well, s of 2 is 166 minus s of 1 is 99 divided by 2 minus 1, which is 1. So if I subtract 99 from 166, that will give me 67. 67 divided by 1 is 67. So the average velocity from 1 to 2 for that position function would be 67. All right, next, from 1.9 to 2. 1.9 to 2. In this case, from 1.9 to 2, well, let's find out what S of 1.9 is by just substituting each t with 1.9. So it'd be negative 16 times 1.9, and that's squared, plus 115 times 1.9. All right, so negative 16 times 1.9, and that's squared, plus 115 times 1.9. And that would give me 160.74. And I already know what S of 2 is. That's 166. So the average velocity, that's going to be S of 2 minus S of 1.9. So this will be 166 minus 160.74 divided by 2 minus 1.9. Now 166 minus 160.7, that would be 5.26. I left the 4 off. So that'd be 160.74 from 166, that's 5.26, divided by 2 minus 1.9 would be 0.1. Divide 5.26 divided by 0.1, that's going to be 52.6. So the average velocity from 1.9 to 2 would be 52.6. And now the next one, 1.99 to 2. 1.99 to 2. And in this case here, S of 1.99, this time we're going to get negative 16 times 1.99, and that's squared, plus 115 times 1.99. All right, so negative 16 times 1.99, and that's squared, plus 115 times 1.99. This will give us 165.4884. 165.4884. And of course, S of 2 again is still 166. So the average velocity would be S of 2, which is 166, minus S of 1.99, which was 165.4884. Oh, that's divided by 2 minus 1.99. So 166 minus 165.4884 will be 0.5116, divided by 2 minus 1.99 will be 0.01. And if we divide that, this will be 51.16. Okay. And I suppose I can fill in these numbers up here. 52.6 for 1.92, and then for 1.99 to 2, that'll be 51.16. Okay. And now for 1.999 to 2, so we're going to find S of 1.999 by just substituting T with 1.999. So this will be negative 16 times 1.999, and that's squared, plus 115 times 1.999. All right, so pretty much if you get the picture, this will be 165.98948.984 is what I'm getting. $165.948.984. Okay. Negative 16 times 1.999, and we square it, plus 115 times 1.999. All right, and then we find the average velocity for that. And S of 2 is 166, minus S of 1.999 will be 165.948.984. That's divided by 1.999 minus 1. I mean 2 minus. The other way around. 2 minus 1.999. All right, so if I subtract that numerator, that would be 0.051016. The denominator will be 0.001. This will be 51.016. So you're pretty much going to get an idea where this is going to be approaching as we get closer and closer to 2. All right, that last box, or that last number in the table, the last interval, that's 1.9999 to 2. So we just do S of 1.9999 is equal to negative 16 times 1.9999 squared plus 115 times 1.9999. This will be 165.99 48998. Doing this on the calculator. And then the average velocity is 166 minus 165.9948998 divided by 2 minus 1.9999. If we subtract our numerator, that would be 0.00510016 divided by 2 minus 1.9999 would be 0.0001. And you'll end up with 51.0016. Okay. Now, by looking at this, we can see that as we get closer and closer to 2, our average velocity will be getting closer and closer to 51. Okay, so here we can say that the limit as t gets closer and closer to 2, that function will be 51. Okay. All right. Let's look at one more of these, and then we'll go into doing the slope of the tangent line. Let's say we had a position function that was written like this: S of t is equal to 21 divided by t plus 1. And here I want to compute the following table with the appropriate average velocities and then make a conjecture about the value of the instantaneous velocity at t is equal to 0. Okay. So let's start from 0 to 1. Okay. All right, so let's find S of 0. Here, that's 21 over t plus 1. So it'll be 21 over t is 0 plus 1. So that means I'm going to have 21 on top, 1 in the denominator, 21 divided by 1, which will be 21. So at 0, we're going to have 21 for that S of t function. And then for S of 1, this time t is going to be equal to 1, so it'll be 21 over t, which is 1 plus 1. 1 plus 1 is 2, so 21 divided by 2 is going to be 10.5. So at S of 1, I'm going to have 10.5. Now for the average velocity, that's of course S of 1 minus S of 0. This is going to be 10 0.5 minus 21. Over b minus a, 1 minus 0. So 10.5 minus 21 will be negative 10.5. And negative 10.5 divided by 0 minus 1, which is 1. That's going to end up being negative 10.5. So the average velocity from 0 to 1 will be negative 10.5. Now from 0 to 0.5. Well, I know what S sub 0 is. That's 21. Okay. Now, what about S sub 0.5? That will be 21 divided by t is 0.5 plus 1. So that means I have 21 over 0.5 minus 1 will be 1.5, and 21 divided by 1.5 would be 14. And now we can find the average velocity. I'll write that off to the right. This will be S of 0.5 minus S of 0. 14 minus 21 divided by 0.5 minus 0. 14 minus 21 is negative 7. 0.5 minus 0 is 0.5. So 7, negative 7 divided by 0.5 would be negative 14. So from 0 to 0.5, that average velocity will be 14. Now from 0 to 0.1, notice that the second number is getting smaller and smaller and smaller. That means it's getting closer and closer to 0. That means S of t will be getting closer and closer to some number. We don't know what that is yet. All right. Again, S of 0 is 21. But for S of 0.1, this will be 21 divided by t is 0.1 plus 1. So it'll be 21 divided by, in this case, 1.1, which will be 19.0909. And I will go no further than that. So the average velocity will be 19.0909 minus S of 0, that's 21, divided by b minus a, 0.1 minus 0. So here I'm going to get something like a negative 1.9090 divided by 0.1. I'm saying negative 1.9091. Negative 19 points. Okay. And by the way, if I rounded this off, this will be rounded off to 1. Negative 1.9091. So this will be negative 19.091. Okay. Now from 0 to 0.01. Well, S sub 0 is 21, but S of 0.01, this will be 21 divided by 0.01 plus 1, or 21 divided by 1.01. And I'm going to say this will be 20.792. I'll say that because notice that this decimal repeats 0.7920792, and then they rounded it off to a 1. Now for the average velocity, this will be that 20.7921 minus 21, all divided by 0.01 minus 0. This will be negative 0.2079 divided by 0.01, which ends up being a negative 20.7921. Yeah, let me write that there. That looks sloppy. Okay, so this is negative 20.7921 from 0 to 0.01. And then finally from 0 to 0.001, again, S sub 0 is 21, but S sub 0.001, this will be 21 divided by 0.001 plus 1, or 21 over 1.001, which would be 20.9790. And I'll stop right there. So here the average velocity. The average velocity will be that 20.9790 minus S sub 0, that's 21, divided by 0.01 minus 0, 0.001 minus 0. So I got negative 0.0209, and I might as well say 79 divided by 0.001, because that's what I had here. Then I'm going to divide that by 0.01, which will be negative 20. Oops. Okay, I have to do this by hand. Let's see, 21 divided by 1.001, that's this, minus the 21, that's going to be that. Divide that by 0.001. That's what I wanted, negative 20.979. All right. Now, go ahead and fill in that negative 20.979. Now, as we let the second endpoints get closer and closer to zero, the average velocity is getting closer and closer to what value? In this case, getting closer to -21. So that limit as t approaches zero, s of t would be -21. Okay. So that's how we use a position function to find out where that position function is getting closer and closer to when we let t approach some specified value. Okay, last thing in this video is going to be the slope of the tangent line. All right, the secant lines approach a unique line called the tangent line, as I illustrated earlier, a line that touches the graph at a point, okay? And I did talk about that because I did show you the green line here. That green line that you see there is what we call the tangent line. That's going to be the line that touches that graph at a point. Because tangent line always touches the graph at a point. And the slope of the secant line, which is this illustration, that notation approaches the slope of the tangent line. And this is the notation, m with the tan, the slope of the tangent line at a point. So that means that the slope of the tangent line is also expressed as a limit. All right, so now let's take a look at this example, number 6. Let's say I want to find the function f of x equal to -5x squared. And I'm going to make a table of slopes of secant lines and make a conjecture about the slope of the tangent line at x is equal to 3. Okay. All right, so let's start with finding out what f of 2 is and f of 3. Using that function f of x equal -5x squared. Okay, so that's going to be -5 times x, which is in this case going to be 2, and that's squared. And then for f of 3, it'll be -5 times 3, and that's going to be squared. So let's start with -5, and we square it. -5 times 2, and we square that. That's going to be -20. And then at 3, it'd be -5 times 3 squared, which would be -45. And then find the slope of the secant line. That's going to be f of 3 minus f of 2, -45 minus -20. Divided by 3 minus 2. Because it's always going to be a minus b. That's your a and that's your b. B minus a will be 3 minus 2. Let's see. -45 minus a -20 will be -45 plus 20, which is -25, divided by 3 minus 2, which is 1. -25 divided by 1 will be -25. Okay. And then from 2.5 to 3. Well, we already know what f of 3 is. That's going to be -45. So as you can see here, the endpoints are still at 3. But it's these first points, the first endpoint, they're changing. So we need to find out what f of 2.5 is going to be. So here we're going to have -5 -5 times x, which is 2.5, and that's squared. So -5 times 2.5, and we square it, it will be negative 31.25. So that means that the slope of the secant line would be negative 31. Well, actually, it's going to be negative 45 because that's f of 3, negative 45 minus the second, negative 31.25 divided by 3 minus 2.5. Because it's always b minus a. F of b minus f of a. That's f of b, that's f minus f of a. Now, negative 45 minus negative 31.25 will be negative 13.75. And 3 minus 2.5 will be 0.5. Divide negative 13.75 by 0.5, that would be negative 27.5. So from 2.5 to 2.3, I get negative 27.5 for the slope of that secant line. And now from 2.9 to 3, let's find f of 2.9. That's going to be negative 5 times 2.9, and that's squared. That would give me negative 42.05 for f of 2.9. And then the slope of the secant line is going to be this, f of 3, which was negative 45, minus f of 2.9, that's going to be negative 42.05. Divide that by 3 minus 2.9, b minus a. Well, 45 minus a negative 42.05, that would end up being negative 2.95, and 3 minus 2.9 would be 0.1. And negative 2.95 divided by 0.1 would be negative 29.5. So you kind of see where the slope of that secant line, when we get closer and closer to 3, where it's going to be approaching. All right, let's go ahead and finish these last two. From 2.99 to 3, I need to know what f of 2.99 will be, which is, of course, negative 5 times 2.99, and that's squared. Oops. That'd be negative 44.7005. Negative 44.7005. So that means the slope of the secant line would be f of 3, that's negative 45, minus f of 2.99, that's negative 44.7005, divided by b minus a, 3 minus 2.99. I know that denominator is going to be 0.01. And then negative 45 minus negative 44.7005 will be negative 0.2995. Divide that by 0.01, that's going to be negative 29.95. Okay, and then finally 2.99 to 3. Well, f of 2.99 would be -5 times 2.99, and that's squared. 5 times -2.999, and that's squared. -5 times 2.999 and u squared will be -44.970005. And then the slope of the secant line is going to be f of 3, which was -45, minus f of 2.999 will be -44.970005. All that's divided by 3 minus 2.999. That denominator will be 0.001. The numerator, -45 minus -44.970005 will end up being -0.029995. Divide this, you'll end up with -29.995. So pretty much you can see where this is going to. It's getting closer and closer to -30 as we let x get closer and closer to 3. So that means that the slope of the tangent line, using this notation, the slope of the tangent line, that will be the limit as x approaches 3 of that function f of x. That's going to be -30. It's getting closer and closer and closer to -30 as we let x get closer and closer to that fixed number of 3. Okay. All right, so that concludes this video on section 2.1, dealing with the idea of limits. All right, feel free to email me if you have any questions about anything that's presented in this video or any of the homework problems that are in my math lab.